Alright students, so right now I have this TI-84 Plus and I'm going to show you how to do some hypothesis testing with it for the population mean. So of course you have to turn your calculator on and then you have to go into the stat key. Now there's two things you can do. If you have raw data, you can enter the raw data in the edit menu, and if you're testing with one mean, enter the data for that problem into list 1. If you're testing the difference of means, then you're going to have two data sets, so you would enter them into list 1 and list 2. So that's one option. Another option is sometimes in problems they just give you the statistics. So either way, if you have the statistics, make a note of them, write them down somewhere, and hold on to them. If you have raw data, then enter the data into your calculator. In order to do a hypothesis test, or perhaps maybe a confidence interval for the population mean, you need to go over to tests. Now, a z-test is something we commonly use when the population standard deviation is known. And I'll just do a z-test here, but I will use stats as an example. Mu naught is your H naught value, what they were claiming. Maybe they were claiming 16, who knows. Sigma is the population standard deviation. X bar is the sample standard deviation given to you in the problem. N is the sample size. And mu, this is your HA, your alternative hypothesis statement. Maybe you were trying to see if it's actually greater than. Maybe you're trying to see if it was less than or not equal to. I'm going to pick not equal to, and we'll do a two-tailed test, perhaps. Then you just hit calculate. It's going to say, oh, you were testing to see that it wasn't equal to the claimed value of 16, or whatever. It gives you a z, which this is the test statistic if you're doing critical value method, and the p is the p-value for p-value method. Now suppose you were doing maybe a t-test, because you didn't know the population sample standard deviation, or you have a really small sample, or something like that. Let's select data to give you what that looks like. I'm going to use the raw data that I inputted into list 1. Mu naught, again, is what H naught says it is. It's what the person was claiming. Frequency is going to be 1, and we calculate. It gives you the t test statistic for critical value method, the p-value, which you compare to alpha. It summarizes X bar and the standard deviation and the sample size for you. And that's basically it on a hypothesis test. If you need to do difference of means, then you would do a two-sample z, where it asks for sigma 1, sigma 2 first. So I'm just making up statistics to illustrate how the calculator uses things. It'll prompt you for everything. Of course, X bar 1 is the sample of, the sample mean for the first data set, so on and so forth. Mu 1 here, again, that is your alternative hypothesis statement. The difference of means is greater than 0 equivalates to mu 1 is greater than mu 2. So maybe if that was your option, you would select that. And then you hit calculate. Similar display. It gives you a z-test statistic and a p-value. Same thing in two-sample t-test, but I will use data to illustrate that key. Your first data set should be in list 1, your second data set should be in list 2, or some corresponding consecutive lists. Frequencies, unless you stack your data, that's always going to be 1. Mu1, again, that's your alternative hypothesis statement where you're trying to see if there was a greater difference or a smaller difference or a difference either way. Pooled means pooled standard deviation. Do you have a pooled standard deviation? Usually, if you want pooled standard deviation, it's because you're assuming that the population standard deviations are equal. Okay, so you need to select yes or no on that one. So if the population standard deviations are assumed equal, then you would say yes. And we want to calculate. We don't really want to draw a picture. I like the p-value method, so I always pluck the p-value from the calculator, but again, it does give you the t-test statistic, and you could look up your critical value and decide whether it falls in your rejection region. So that's just a summary. This is the pooled standard deviation, which is pretty cool, because that's kind of a nasty formula to calculate by hand. That's just basically a summary of hypothesis testing for the TI-84 plus. If you wanted to do confidence intervals, they're down here. If you want to do a Z confidence interval, a T confidence interval, a 2-sample Z interval, or a 2-sample T interval, their menus are similar. You pick your input. Do you have raw data or do you have statistics? I'm going to use raw data, let's say, and I know my standard deviation. My population standard deviation is somehow known. I'm using list 1 for my data, and maybe I want, I don't know, an 85% confidence level, but I already see an issue. I've got 2 decimal places. Delete 1. There we go, 0.85, 85% confidence interval. It'll bring it up. It says, hey, the population mean falls somewhere between here and here, and we're 85% confident of that. T interval, very similar method. 2-sample T, 2-sample Z, same kind of thing. Play around with your hypothesis test and your intervals for means, and let me know if you have any questions.